Hi everyone. Today we are going to look at persistence. Actually, although I use the word persistence, it means keeping your data in a way so that you can access it even in a later date or later time. Last week we looked at something called exception handling. This is a very important lesson for what we are doing today also, because when it comes to file management, or in this case we use the term stream, there are a lot of things we don't know that we can do, whether we can, right? For example, when it comes to creating a file, we don't know whether our hard disk has space. We don't know whether we have permission to create files or folders. If you're trying to read something, we don't know whether the file is there or not, right? So because of this uncertain things, we always put these issues, or rather these actions, into the exception handling mechanism. If you remember, we looked at try-catch blocks, right? So when it comes to file management, we heavily use this try-catch block because we don't know whether we have permission, or whether whatever action we are trying to do, whether it is possible. So all this time, we were running our program, we were creating things, but then when we go away, as in when we turn off the computer or when we restart the application, uh, whatever that we have done, whatever data we have entered is gone, because it is not available again to use. Because every time we use our computer, we are storing our information in the RAM area. That is we call it the volatile memory area. So when you turn off the computer, whatever that you have stored is gone, right? Or deleted. When you come back later, it's not there. So we need a mechanism to store this information so that when you come back maybe later or tomorrow, some other date, we need to read that file so that we can come back to the same state as we were before. So essentially, if you're writing a document, we would like to keep a copy of that. Or at least we need to store that. So later we can read it. Or maybe we are reading some information, some data from some device, maybe some file, maybe, and then we want to process that. Rather than asking the user to enter the data real time, we can read that data from a file. So that's another way to look at it. So when it comes to Java, we use the term stream. Okay, stream is like a water stream where things go from one place to another place, and we can read from the stream, we can write to the stream, we can attach a filter to the stream. We can do all that, right? Whether we are reading or writing, we can send it through a filter also. Like, for example, we can detect a certain numbers, certain words maybe, and see whether this is there in that stream. So three things we do: input, output, and also filtering. All right. Let me jump into the presentation so that you can have a look at some theory here. All right. So as you can see, the topic says handling input and output. So we use the term stream, as I said earlier. Now, here's a diagram showing what is going on here, right? So on one side, if you look at the left-hand side, we have the source. On the right-hand side, we have our destination. In the middle is where our Java application is doing some processing, or data processing, we call it. So you notice the source has three ways of getting information, right? Or data. It can come from a file, it can come from a console, it can come from a socket. What are these things? What do they mean? A file, I guess it's straightforward. It's coming from a file that is stored in the hard disk, right? So what is console then? The computer has two main devices. We call them the console. One is the keyboard and the other one is called the monitor, right? So the keyboard is the input console, monitor is the output console. So since we are talking about inputting or the source, in this case, we are talking about the input stream or the keyboard. Socket is another mechanism to connect to the internet, as in another computer or another a gadget that is sending us the data. It might be a weather control system, it might be a machine in a factory, whatever it may be, any device sending us data through the network, we call it a socket-based application. Now, if you also notice, right after the source, we have a term called input stream, right? So that's the term we are using, stream. And the data is coming as binary. So we are reading this data from the input stream. Now, remember, we don't know whether they are sending us the English word, whether they are sending us any binary data like photos or music or video. We have no idea, right? We get everything through the input stream. Then on the output side, we have output stream. We also have three destinations. We have a file, we have a console, then we have a socket. Okay. So we can store information onto a file. We can send the information to the monitor, that is the output console, or we can send the information or the data to another remote device. It might be another computer, it might be another machine, anything that is connected to the internet. Right? So this is the input-output mechanism. We call it the input stream and the output stream. Now, there are three types when it comes to streams: byte stream, character stream, and buffered stream. Okay. Byte stream is very straightforward. We get or we send data as bytes. So this is suitable for music file, binary file, like photos maybe, videos maybe, anything. Anything that is connected with the binary data, we use byte stream. Remember, Java by default uses Unicode for text, isn't it? Because of that, we also have a dedicated character streams to handle the Unicode. So you may be storing information as Sinhala or Tamil or English or German, Japanese, whatever. So if that is the case, you should use the character streams to read and write the character data. The difference is character data, every single unit has 2 bytes, whereas the byte stream, every unit has 1 byte. So just to remember, okay, if I'm using binary data like photos and pictures and whatever videos, then use byte streams. Or including classes and objects if you're storing, we use byte streams. If you're using characters, then we use character streams. The third one is very interesting, buffered stream. Now there we have buffered input, buffered output. We also have a buffered reader and a buffered writer. Now buffered mean like this. Now the CPU, is running very fast, right? Now in my laptop, my CPU speed about 3 gigahertz. Now, if you look at a typical hard disk, a mechanical hard disk, magnetic hard disk is far slower than the CPU. Of course, SSDs are very fast, but the usual magnetic hard disk are very slow. So if you are writing something to a magnetic hard disk, it will take a long time to write to the magnetic hard disk, right? But the CPU is very fast. So what we do here is we will write to something called a buffer, something that is in between the CPU and the hard disk. And then the CPU can do something else now, meaning CPU will write the information to a buffer and then continue to work. So there has to be some other program reading from the buffer and then writing to the hard disk. Same can be said about reading also. We can read from the hard disk to the buffer. From the buffer, we can read to the computer. So that way, CPU can run very fast. And there are different code example that I can show you how to do these three also. This diagram is an interesting one. It shows how this is organized using Java classes. This chart is not only a name, but this is also shows you the exact Java class name that is used in stream processing. So in Java, everything starts as object. And in this case, we have an input stream and output stream. These are two different object or rather classes we can see. And if you take input, we have file input stream, byte array, file input, object input. Now the file can be buffered input stream or data input stream. Similarly, output also we have file output, byte array output, filter output, object output. Now the filter output again can be broken down into data output and buffered output also, right? So let's take each one and try to understand how to actually use these in our real world examples. So the first one, the byte stream. So Java byte streams are a typical type of I/O stream used for handling input of raw binary data. What do you mean by raw binary data? Anything that is non-text. It can be photos, audio files, or even object files that we're using can be stored as byte streams. Okay, so they are particularly useful when dealing with binary data or when you need to handle data at a byte level. Let's say you are getting information from a device or you want to send information through a network to some other machine. Then we use byte streams. Here's an example of reading from a file. I'll show you a full example later, but here, what we are doing here is we are using a class called file input stream. Okay, so FIS is my object name, and I'm creating an object out of the file input stream class. And to that, I am passing a file name, in this case, input.txt, right? So I'm passing a file name and my FIS object is now reading that file. So when I run the next line where I'm reading the entire file and then storing that in a data called, or rather variable called data, my entire file content is now stored in a variable called data. Okay, this is reading from a file. Similarly, we have a same sort of mechanism where if you notice we have a file output stream class, and to that also we give a file name output.txt. So what you're doing there is we are outputting whatever that is in a, let's say, variable into that file. So in this example, I'm taking the variable called data and then passing on to the FOS with the write function, right? So in this example, we are looking at reading a bunch of bytes from a document and also writing it back to another file. Next one, remember Java uses Unicode for characters. So in this case, we are reading Unicode characters, right? And we are writing also Unicode characters. And they provide a very convenient way to read and write strings because this is to do with characters, right? So very similar code. We are using, in this case, file reader class. Yeah, so the object name is reader. To that, we are passing on a file name, input.txt. And then we are reading that file into a variable called data. Same thing we do with the writing. Yeah. So, like I said, this example looks at reading a character stream, or in other words, text file, right? The difference between a text file and a binary is in Java, text files are 2-byte Unicode. Our next example is actually here using the file reader, right? Here we are using a little deviation from that where we are reading things into an array. Okay, so in this case, we are using the character array reader and the character array writer. This one reads the whole thing into a one variable, whereas here we are reading it to an array, individual characters array. The advantage is we can process these individual characters within the array. All right, so as you can see, we have a variable called character array. It has a character array data type, and we are loading this string into the character array. And then we are reading that character array into the reader variable, right? The same thing can be done when it comes to writing. So writer is the object name, and to that we are writing the hello Java characters. So this is not a string, they go into a character array. The next one is an interesting one, like I said earlier, buffered streams. So we are using buffers between the CPU and the peripheral or the device. The biggest advantage is we improve the speed or the efficiency of the speed when it comes to accessing these things, right? Let me put it this way. Now, when you are reading from the hard disk, say for example, generally we don't read one byte at a time, although we say byte reading, byte writing, or character reading. We don't do that. We are actually reading a whole lot from the hard disk, like sector, sometimes we call it, or a track maybe sometimes. Yeah. So we do read the whole thing, keep that in memory, and then we do read a small piece at a time. Writing also same. Now, buffered stream actually officialize that or make it happen it that way. Yeah. So if you notice here, what we have done here is we have a file input stream, right? So we are creating the file input stream, and our object name is FIS. And that one we are passing on to the buffered input stream, right? So in this case, when you're reading the data, so what we're doing here is we are reading from the buffer. The BIS is the name of the object. From there, we are reading it, right? And that goes into the variable called data. Similarly, when it comes to writing, also same thing. So we are writing our data into the BOS object, which is the buffered output stream. So the data is coming from this variable called data, and we are passing on that to the buffered output stream. So we looked at byte, character, and buffer, right? Those are the three ways of handling our streams. Okay, here's another example. Here's a file. I'm reading that, buffer to reader, and then it goes into the variable BR, and there we use that and store the information onto a variable called line. Same is here, writing a line to the BW, which is a buffer to writer. Okay, so far we looked at normal data, bytes and characters. What about storing objects and reading objects? What is the example? Where can we use this? Now imagine we read some information about students. So maybe we read about 5 students, maybe 10 students, maybe 20 students. And I want to store that information in the hard disk. Let's say I get input from the customer for 10 users. The user is entering data. Let's say 10 records, not just simple data, maybe complex data, their name, their age, their marks, their NIC number, whatever, right? Lots of data per user. We take information about, let's say, from 10 users, and then we store that in the hard disk. So later, maybe today, maybe next week, maybe next month, we can read that data from the hard disk and load it back to our objects, right? We are not reading byte stream, we are reading object streams. That way, we don't need to translate the data or the byte and characters into the object. So this is known as object serialization. So what does that do to us? It is a mechanism that allows object to be converted into streams of bytes. Now, these are not characters, by the way, they are bytes. Okay, so we can store our objects in the hard disk, send it through the network to some other computer, anything we want to do it. Yeah, and we can also translate this into various data types also. Now, remember, Java has lots of data types. List is there, stacks are there, various things are there. So we can very easily translate these things as well. Okay. So in order to do that, you need to do a couple of things. One, you must import this library called the serializable library. Okay, import java.io.serializable, number one. Number two, you get an interface from the serializable. So you have to bring that interface into your class through the implements mechanism. Remember the interfaces? So this is not extending. This is not parent-child class. This is interface, right? So public class, my class, implements serializable. So serializable is a interface that we are using within my class. So once you do that, you can basically convert any object to something serializable and store that in the hard disk, right? So here is an example. So in the first one, actually, this must go through try catch block, otherwise there will be issues. So we create a file name called object.ser because ser stands for serializable. This is the usual norm when it comes to storing the data, object data in the hard disk. So I'm creating a file called object.ser. Okay, so OOS is my output object. And then here I'm creating a class, some class, students or car or vehicles, animal, whatever. And then my object name is obj. And there I am writing the object to this. See, my obj, I'm sending it to write object of the OOS, which is here. So I'm sending my object to the object output string. That's what I'm doing here. Okay. Similarly, when you are getting it back from the hard disk and putting it to the classes or the objects, that process is known as deserialization. Okay. So deserialization is the opposite of serialization. There, I'm reading my file, object.ser, and then what is this in the bracket? This is called typecasting. I'm converting the OIS read object onto my class, right? So which is what I use here, my class, right? And then OBJ has the data back from the hard disk. Yeah, back from the hard disk. By the way, I'm using exception handling here. Do you see this line? This is the O. So IO exception O, class not found exception. So sometimes this class may not be found, or some issue may have come. So we have a try catch block to capture it. Right, that is one more thing we need to realize when you're doing this object serialization. Now, sometimes your object might have information like maybe secret information, like say password or credit card information and things like that, which you don't like to store in the serializable file, okay, for some reason. Now, in that case, you can put this word called transient in front of the variable definition, and that will not be stored in the hard disk. So for example, I have a variable called sensitive data. That's the name of my variable. It's an integer type. It is private to the class, and I put the word transient in front of that. So when I do it, this will not be stored along with your data. Okay, so this is suitable for secrets and credit card information, password, stuff like that. Okay. So what did we cover so far? We looked at streams. We realized there are three types. There are binary type, then there are character type, then there are also buffered types, isn't it? So we looked at binary, we looked at character, we looked at a buffer. And then we also looked at object serialization, because that is another way to store objects in the hard disk. We also realize at the last point that there are certain things that we do not wish to store along with the object serialization. For that, we use transient. Okay. I'll be sharing some code please have a look at the blog to understand some samples of each case. I'll see you next time.